Okay, now we have our arch 6, the arch effect. That's the result. The coefficients, sorry, the test result highly significant. Reject the coefficient is equal to 0. So there's arch effect in our squared residue. Once we have identified the arch effect, we try to construct our arch model. Right? How to construct the arch model? Use the model. Model for financial data for the category. Right? Gauge model use PC game. Choose the right variables is the squared residues. Right? Arch is dealing with squared residues. Okay. Now is choose the right order. For gauge, T here, right? The T order of T is for the log order of conditional variance. The Q is for the log of the squared residue. Right? If the order of T for the log the value of conditional variance equal to 0, what do we have? We have an arch model. Right? In here, if we cover this term, we get arch 1 because we have one log of squared residue. Right? In this case, for arch, your T will equal to 0, the Q will equal to 1 for arch 1. Equal to 6 is arch 6. Right? We change the order. P equal to 0, Q equal to 6. Right? Because we have identified the order of arch in the last step. Right? Order set. Okay. Now we have our arch model, right? With 6 blocked in the squared residue. Once we have construct our arch model, we need to do 2 things. One is you need to test the autocorrelation for the arch model by ticking the box squared residue autocorrelation and the fundamentals. Right? This is different from what we have done in ARMA. In ARMA, we will tick the box residue autocorrelations, but in arch or gauge, we need to tick the box of squared residue. Right? Test. Not change that. So click OK. According to our fundamental statistics, the residue for arch model has no autocorrelations, so our model is not misspecified. The thing is, we need to perform the restrictions exclusion test, exclusion restriction test for each of the log term. Here we need to keep alpha 0. We repeat this step process 1 by 1. We need to conduct the exclusion restriction test for each of the log terms. Right? Next thing. Now we have built our arch models. Why we need a gauge? In our seminar, we have already discussed the problem. Arch model, we cannot identify the optimal order or optimal number of orders for arch, right? The second thing, even we identify the orders, the number of orders for arch is extremely large for arch 50 or arch 60. But and if you have a large number of orders, it's more likely to have a negative coefficient. We have a non-negative conditions for arch and clutch because we are dealing with conditional variance. Right? Also, we are dealing with squared residues. In this case, all the coefficients should be non-negative. If you have extremely large number of orders in arch, the coefficients are more likely to become negative. If you have a negative coefficient, the model is misspecified. That's why they introduced gauge. Gauge 11 is equal to the arch model with unlimited orders, arch infinity. Right? So now we're gonna construct our arch model. Same stuff.
But then
Sure.
we just formulated an action.
Sorry?
We just used that.
We use the gauge, but the P order, the order of P is equal to 0, so it will be our arch model. Yeah. The P is dealing with the log value of conditional variance. The Q is for the log value of squared residue. Next. Okay, continue. Change the order, P equal to 1, Q equal to 1. This is your gauge 11. Okay, and again. Now we have our arch 11 model.